Right, so in the last couple videos, we've been looking at this new expression log showing us the power, right? What power, no, let's convert this log back, right? We have a base of 8, we have the answer of 64. What power would do that? So we could look at it as a log expression, but if we write it in a format we know a little better, what power is going to take 8 and give me 64? That power has to be 2. In other words, x equals 2. Cool. This next problem, though, is not quite the same. Notice the x position has changed. So we're asking a different statement here. What power takes 2 and gives us x? That power is -4. So 2 the power of -4 equals x. Oh, I can actually solve that. A negative would make it a fraction. 2 to the 4th is 16. So x must be 1/16. Okay, notice the position has changed and therefore the question has changed. This time it was the argument we did not know. It was the answer to the exponential equation we did not know. All right, here it looks like it's the base that we don't know. What base to 1/2 power is equal to 5? Well, that's saying what's the square root of x is equal to 5? Oh, x must be 25. The base must have been 25. So 3 different versions of this log place that you could have missing pieces. A lot more questions that you can ask than simply just this first one, right? All right, and you could even break this down even farther. Here we have some logarithm statements, some logarithmic questions, but there's even more involved. Notice the things inside the arguments are not just x. It's not just an x in this place. That doesn't mean it changes. So what are we going to do? Well, we're going to solve this the same way we solve any other thing. We're going to go one issue at a time and pick a tool to fix that issue. An issue here, we want x equals. The issue, the farthest thing from x on that side is the log. So let's convert it back. 2 to the 3rd power is going to equal this thing. And actually, sorry, I'm going to write that a little higher just so we have some room. 2 to the 3rd power is equal to this argument. Okay, so we have undone the log. A log is a new thing. It's not like sine, cosine, tangent. It actually doesn't even hold that much power, right? It's not a special calculator button. It just means this is 2 to the 3rd. The power was 3. So we'll put the power back in, and we get that 8 is equal to 4x plus 3, because we can simplify 2 to the 3rd. Move the 3 to the other side, you get 5. It looks like our x is 5/4. Beautiful. Cool. Going over here, kind of the same idea. How do we undo the log here? Let's undo it. 5 to the 2nd is equal to x squared minus 10. 25 is equal to x squared minus 10. Just kind of clean that up a little bit, right? Just undoing the log. That's the only new step. We know where to go from here. It's a quadratic, but it's not a quadratic with a single x term, so I can just start solving to one side. That would be 35. And so we get that x is equal to the square root of 35. Beautiful. Over here, last one. Again, the first, I know a lot of people are going to jump to, oh goodness, there's an x squared and an x. I got to factor. I got to do all those things. But guys, it's still stuck in a log. You can't do anything until you get rid of that log, right? You got to get rid of that thing that's the farthest away. So let's do that. 8 squared is equal to that thing inside the parentheses. Well, what is 8 squared? 8 squared is 64. And now all those panic moments about factoring and whatnot. 64 is still not 0, so let's move it to the other side. Why on earth would I not try to move things towards the 64? Compare it to the last problem. No x there, but there's a single x there. So I got to put things together so I can factor them. All right, minus 64. Okay, so we got to factor that now. 64, 1 and 64, 2 and 30, 2 and 32. 2 and 32 might work because they would add, one's got to be negative, so it would go back down to 30. I'm thinking plus 32 and minus 2. And so our two answers, the x equals -32 and x equals 2. All right. Quick double check on this though. Remember that exponents have a domain thing to them. Exponents cannot be negative. right? Well, the exponent itself can be negative, but it can't spit out a negative. There's no exponent that's going to take a positive number and give you a negative number. So since our base here is 8, let's just double check these really fast. We'll double check them really fast. If I plug in negative 32 squared plus 30 times negative 32, I get a really big negative number, negative 1984. So all of a sudden I get this. All of a sudden I get this, and I get something that doesn't exist. And so this is actually a garbage answer. X is equal to 2. All right, I'll see you in the last video for the word problem.